Right, I hope you're all well following on from the exam. This is basically the first step that we're going to take in terms of more advanced work with me. So at GCSE you did sequences and series and you do them at a certain level, which is, a reasonable, adequate level. What we want to do is we want to take them further, quite a lot further, because it turns out that sequences and series are really, really important things in maths. So first of all, just to describe what they are, a sequence is any pattern of numbers that's just written down in a list, usually across the page, usually separated with commas. So for example, this sequence is just the sequence of the odd numbers. You could have the sequence of the square numbers, or it might have no pattern at all. It could just be, 4, -3, 9, 2. It doesn't have to have a pattern. It's just any set of numbers going across the page. A series is what you get when you add up a sequence. So in some GCSE textbooks, they get this wrong, but that's what it is. So a series, for example, might be 1 + 3 + 5 + 7 + 9 and so on. Another name for this that we will use a lot later on, because both are used, is a progression. So a series is exactly the same thing as a progression. Some things to notice. So first of all, if you look at this sequence here of the odd numbers, I've written ... makes it look like it's going to go on forever. It doesn't need to. You could have a sequence that's just finite. So there you go, there's a sequence of the first 5 odd numbers. But similarly, it could go on forever, like this. If you're looking at a particular element, a particular piece of a sequence, it's called a term. So this would be the second term, the fourth term of the sequence. And the language between sequences and series is pretty much shared. So again, that would be the second term, that would be 3 or a +3, and then the 7 would be the fourth term. So just some adjectives that you might come across, we will come across, to do with sequences and series. So first of all, you've got an arithmetic sequence or an arithmetic series. And this is from GCSE. It just means there's a constant difference as you march up the terms. So you can see that here, for example, as we go from left to right, as we march up through the sequence, we're adding 3 each time. So this would be an arithmetic sequence in this case. If these were all joined with pluses, it would be an arithmetic series or an arithmetic progression. So there's a constant difference. It could also be negative though. So you could also have something like 10 followed by 8, followed by 6, followed by 4. And in this case, you're going down by 2. The difference is -2. That's also arithmetic. Geometric. Well, for geometric, you're going to multiply by a constant as you go across. So in this case, you can see we're multiplying by 3 as we march across from term to term. So we're multiplying by a constant rather than adding a constant. Again, it doesn't have to be a whole number, it could be a fraction, it could be a negative number, but we're multiplying by a constant amount as we go from left to right. Periodic just means there is some kind of repeating pattern. So here you can see this little sequence goes 159, 159, and if we assume it goes on like that forever, you can see that, the first term, and then the fourth term, and then also the 7th term, they're all going to be equal to each other. And in the same way, you've got the second term equal to the 5th term, and so on. So it's just a set pattern that repeats and repeats and repeats. And then finally, a word, well, really 2 words we're going to use a lot, convergent, and then also its opposite, divergent. So convergent means tends to some type of limit. So in other words, if you look at this sequence here, it goes 1, a half, a quarter, an eighth, a 16th. So this is geometric because we're multiplying by a half each time. You can see you get, kind of metaphorically putting my little quote marks around this. This is getting infinitely close to, as close as you like, to 0. Yep. So if you want to get to within a billionth of 0, eventually this sequence will get there. So we say this is convergent. We say it converges to a limit, and the limit is 0, or we also say it tends to a limit. If a sequence doesn't converge to a limit, so I'm just going to put this up here, so if not, we say that it is divergent, like that. So So divergent can be something that's just getting bigger and bigger and bigger, or smaller, and so it could be something like this: 1, 2, 4, 8, 16, ... This sequence is just heading off towards infinity. Also, it could be something like, say I had something a bit weird, like 0, 1, 0, 1, 0, 1, ... So this isn't converging. Yep, this isn't getting closer and closer to any limit. There are other more complicated phrases that are used, like absolutely divergent, that means heading off to infinity. But from our point of view at this early stage, either something is convergent, and we'll call it convergent, or it's not and falls into the divergent category, even though divergent sounds like it should be heading off towards plus infinity or minus infinity. But the key word really is about convergent. Does a series or a sequence converge? One last thing on this again, we've done all of these for sequences. Well, like I said, all these phrases also apply to the idea of progressions, as we'll see later on, or series, as we'll see later on. Also, this is not a comprehensive list. You've got arithmetic sequences and geometric sequences that we'll think about a lot later, but there are billions of different types of sequence and series. There are quadratic sequences, for example, that you've seen before at GCSE. There are, series of the cube numbers. So these are just adjectives that we might drop in describing a sequence or series.